Hello there, welcome to Samuel Academy. My name is Samuel. In this video, I want to explain how to derive the cosine rule. The cosine rule is one of the rules in trigonometry that is used to solve triangles. Another rule is the sine rule. Let us begin to derive the cosine rule. Let us consider triangle ABC with sides A, B, and C. In this triangle, there is a perpendicular that is dropped from point C to the line AB at this point. So it forms right angles with this line. Okay, and this distance AB is equal to C. And from this point A to this point, it is x. Therefore, from here to this point is c minus x. We want to write an expression for a in terms of a squared. Using Pythagoras theorem, we find that a squared is equal to h squared plus c minus x squared. A squared is equal to h squared plus c minus x squared. If we expand this term, c minus x squared, we get c squared minus 2cx plus x squared. Alright, so a squared is equal to h squared plus c squared minus 2xc plus x squared. But from this part of the triangle, we find that h squared is equal to b squared minus x squared. That is, using Pythagoras theorem, this side squared, b squared is equal to h squared plus x squared. Therefore, h squared, which we need, is equal to b squared minus x squared. Alright? So, this value of h squared, that is b squared minus x squared, we can substitute in this equation here. So, a squared is equal to h squared, which is now this one here, b squared minus x squared, then plus c squared minus 2xc plus x squared. Now, in this equation, on the right hand side, we find that minus x squared cancels out with the plus x squared. So we remain with the a squared is equal to b squared plus c squared minus 2xc. Alright. Now, in this part of the triangle, we have this angle A, and the cosine of this angle is equal to the adjacent side over the hypotenuse. So cos A is equal to x over b. In that equation, if we make x the subject of the equation, then we find that x is equal to b cos A. So x is equal to b cos A. So we can substitute the value of x here in this equation here. So where there is x, we put b cos A. So we find that a squared is equal to b squared plus c squared minus 2bc cos A. Alright? Now, that is the cosine rule. And it can also be shown that b squared is equal to a squared plus c squared minus 2ac cos b. That is, b squared is equal to a squared plus c squared minus 2ac cos b. Similarly, it can be shown that this side c squared is equal to a squared plus b squared minus 2ab cos c. So that is the cosine rule and how we can derive it. And then we want to see how we can apply that knowledge to solve triangles that require the cosine rule. We have that exercise as an example. We have the triangle ACD. The side AD is equal to 15 centimeters. The side AC is equal to 12 centimeters. And these two angles are given. Then we are required to find the length of the side CD, alright, to one decimal place. This is how we do it. Using the cosine rule, we know that the required side CD squared is equal to AD squared plus AC squared minus 2 times AD times AC cos 30 degrees. Okay, CD squared is equal to AD squared plus AC squared minus 2 times AD times AC times cos 30 degrees. So CD squared is equal to AD squared, which is 15 squared, plus AC squared, 12 squared, minus 2 times 15 times 12 times 0.866025. 15 squared is 225 plus 144, you get 369, minus this times this times this times this, you get 311.769. The difference here gives you 57.231. That is the value of CD squared. So to find CD, you find the square root on both sides. The square root of CD squared is CD. And the square root of 57.231 is 7.6. So the answer is CD is equal to 7.6 centimeters to one decimal place. So that's how we solve triangles using the cosine rule, in which we have two sides given and an included angle, or two angles and one side. So I hope this video has been of benefit to you. So I want to request you to subscribe to Samuel Academy to be able to see more videos in chemistry, in geography, physics, and weather, and other disciplines, and also to be able to promote my work so that more students can access this work. Thank you so much.